Oh, hello everyone again. So now we will attack the exercise number 2. Exercise number 2 is very simple. First question, we are giving you a polynomial, third order polynomial, third degrees. Create a script exercise 2.1 underscore 1 permitting to calculate the roots of this equation. This is a polynomial equation. You will use directly the function roots. So you would define it as a vector or as a matrix. Let's go here. So my matrix or my vector P is simply equal to, I have, as written here, 1 minus 6, 11 minus 6. 1 minus 6, 11 minus 6. So 1 minus 6, 11 minus 6. Okay, x cubed minus 6x2 plus 11x minus 6 equal 0. So the results of the roots, are roots of my P. Okay, you're on. Okay, no problem at all. So this is your result. 3, 2, 1. So if you apply, you know that for this, if you substitute by 1 minus 6 gives you minus 5 plus 11 give you 6 minus 6 equals 0. 2 also, 3 also. There are roots of the problem. So now like this, first question is done. Okay, so I close this. I go to the second one. Second question, I prepared the response for this, a part of the response. They're asking you to create exercise 2 underscore 2, and this, and we want to know, we want to solve the equations above using we want to solve. This is not the objective issue. The equation above using Newton method by defining one by one by defining a function, because I made a change. By defining a function f of x, and the function of x would be this, and implementing the end limit of for the case, because we have one case, permitting the sum of x of equals 0. I have to say. So it is very simple. You have to calculate f and first derivative of f. This is the first question. Define for the present case the function f and f prime, and write the because we kept only one equation. Before I have many equations. For the expression in a comment at the top of the exercise 2. So I've done this. You have your function f, and you want to solve f equals 0. This is x cubed minus 6x2 plus 11x minus 6 equals 0. And the first derivative is 3x2 minus 12x plus 11. This is f prime of x. So if you want to implement now, so create a script permitting to implement and to calculate the solution of problem 1. You have to run this. This is your succession. You have to run this succession until you have convergence. So if you do it as simple as this, you will write your epsilon, your first guess of your result 0. We know that the results are 1, 2, and 3, but suppose you don't have this result and you don't have a polynomial, you have a nonlinear equation. You will do it using one of these methods is the method of Newton method. As I said again, so we are using just this. Xn plus 1 is equal to xn minus f of xn divided by f prime of xn. This is the algorithm of Newton. It's not a perfect algorithm, you know. Sometimes you have 0 at the denominator here. There are some techniques, special techniques, how to solve this kind of. I can add a perturbation here or something like this to avoid dividing by 0. But MATLAB solve this kind of problems. Anyway, in this case, I define x1 as a first guess. This is the first guess. This is your first guess. Okay, so if you have many roots, many solutions, many zeros for this function, the first guess will give you will conditions what final result you will have for this convergent succession. And we can try it, by the way. So x2 is equal to x1 minus f of x1 divided by f prime of x1. So here you do while abs of xn plus 1 minus xn bigger than epsilon n is equal n plus 1. Xn plus 1 is equal to xn minus f of xn divided by f prime of xn until you have this convergence, and you can take an epsilon equal to, here they asked you to take an epsilon equal to the 10 exponent minus 3. I took in my example 10 exponent minus 6. I can take 10 exponent minus 3, no problem for this. So if you run your script and you get your result res equal to 1. Why 1? Because this is a third order polynomial, so if you take x0 equal to 0, you will converge to 1. If I take my x first guess equal to 3, for example, or 5, if you run with 5, okay, you will get, okay, your result equal to 3. If you take, I don't know, for example, 2.5, if you take 2.5 and you run, you will get, as a result, 1. If you take maybe as a first guess 1.5 and you run, the result would be 3. And if you take, maybe you can take something like -2 or -5. Okay, so if you run it like this, your result will converge for 1. So sometimes you will not get all the rows because of some numerical problem. For me, if you do this script, no problem, you will get the full mark. So it is as simple as this. The conclusions, if you compare A and C, for me, the conclusions is that when you are using on MATLAB the function roots, you have all the roots of your polynomial, but the Newton method is more adequate when you have nonlinear functions to solve or nonlinear equations to solve, but it will not give you all the roots, and it is conditioned by the first guess. Okay, thank you. Let's run for the exercise number 3. Exercise number 3 is very simple with 2 parts. First part for the title, legend, etc. Okay, I will do it like this. Let's go here. So same thing, clear all, close all, C. Did you ask for a time step? Okay, from t equals 0 to 4 pi, h is 10 exponent minus 2. So I have an h equal to 10 exponent minus 2. I have a vector x or vector vector t. The vector time equal to from 0 to, with an increment with a step h, to 4 pi. Okay. So this is my vector time. Can do transpose to be Cannon vector. X is equal to 2 cross cosine t dot product with exponential minus t divided by 10. This is your copy. Y, but for the Y you have here same. Okay. I can define an a value r, no problem, and you write r equal to z is equal to t divided by 10. Okay, and for to plot a contour function, we have to do it using, okay, so we write x, y, z. After this, figure 1, plot x, y, z, title, x label, y label, z label. Okay. You can add a legend here also. Legend maybe. Legend. Function f. Okay. If you run it, okay, this is your legend, this is your function, etc. Okay. So thank you for this first. So for the second part is a function f from r to r. So at x you give x2 sine x if x less than 1, 2 sine to x if x between 1 minus 1 and 1, 2x2 sine to x if x between 1 and 2, and x minus 2 pi if x bigger than 2 pi. So you will write the script and you draw the function between minus 5 and 10. And you add the title, legend to the plot, and you will choose an increment step of 005. So you will take, you will write clear or close all CLC, step 5, 10 exponent minus 2. Your x, it is between minus 5 and 10. Here you will call it not h, or wait. So this is called step. Okay, save. N is equal to the length of the vector x. And we will write a loop for small n going from 1 to big N. Okay. We will do if x of I, if x of n are less strictly than minus 1, we will do what? We will write that y, or f of n, is equal to what? x2 sine x. X of n exponent 2, okay, cross sine of x n. Okay. So after this, you will do else if xn bigger than minus 1 and less than 1. You will do f of n equal to xn exponent 2 by the 2xn. By then, after this, between 1 and 2 pi, you will do also else if to xn exponent 2 sine to xn here tangent to xn and infinity, else f of n is equal to 2xn minus 2 pi, and for the f and for the loop for, and you plot it, but here you have to close brackets, and here also. Okay, you add your legend, do what you want. So if you run, you have your function. So it is as simple as this. Okay, thank you.